Hello and welcome to Group Three's presentation on how Amazon Web Services and cloud-native machine learning systems can enhance financial trading. My name is Jonathan Matos, and I'll be taking care of the first portion of this presentation. Here's our table of contents providing a quick overview of our speaking notes for this presentation. But first and foremost, what is algorithmic trading? Algo trading is the use of computer algorithms to automate the process of buying and selling financial instruments. These algorithms follow preset rules, often based on timing, price, quantity, or other market signals, to execute trades without human intervention. The primary goals of these algorithms is to minimize latency, eliminate emotional bias, and take care of small market inefficiencies that humans might not be able to catch in time. In essence, it's all about trading smarter, faster, and more efficiently. And as for how we trade more efficiently, we use financial prediction. Financial prediction systems rely on various types of data. This includes traditional financial data such as historical prices and volume, as well as more modern inputs like the news or alternative data such as web activity and trends. By using machine learning, we can forecast variables such as stock prices, predict volatility, or even mitigate risks using machine learning and statistical models. By training these models on diverse data, we can uncover patterns that help us guide investment decisions or improve risk management. So, what is it? Amazon Web Services, and why would we use it for this? Amazon Web Services is the leading cloud platform known for its reliability, scalability, and vast ecosystem of services. For machine learning trading systems, this means you can quickly scale up computing power during market hours and scale down to save costs when idle. Amazon Web Services offers a pay-as-you-go model that makes experimentation and development cost-effective. It also provides integrated services such as SageMaker for model development and Lambda for real-time event-driven execution. With a global infrastructure, low latency, and built-in security, Amazon Web Services is a strong foundation for modern financial systems. Beyond trading, Amazon Web Services is powering innovation across industries. In data and analytics, AWS provides real-time processing and large-scale storage solutions. For Internet of Things, it helps connect and manage millions of devices. Machine learning tools are being used in everything from voice assistants to recommendation engines. In healthcare and life sciences, Amazon Web Services supports genomic research and secures patient data analysis. In financial services, firms up its use in fraud detection, personalized banking, and regulatory compliance. And finally, in the public sector, Amazon Web Services secures cloud services for governments and educational institutions. The versatility of Amazon Web Services makes it a one-stop platform for both innovation and operational efficiency, and we've included some informational graphics showcasing some of the services they provide.
So here is an overview of our system architecture. We start at the top left with the AlphaVantage API, which is our external source for market data. You get things like historical and real-time open, high, low, and close prices, volume, and any other technical indicators that we might think is useful. The data is fetched at regular intervals, and we store that using Amazon AWS S3, which is our centralized and secure data lake. From there, we move into the data preparation phase, which all happens inside of Amazon SageMaker. And we're using Jupyter Notebooks for interactive data exploration and pre-processing. This could be cleaning the data, visualizing patterns, and preparing the data set in a format that's suitable for modeling. Once the data is prepped, we train our machine learning model. And here we decide to use XGBoost, which is well suited for structured financial data. During training, we also run some hyperparameter tuning, which optimizes performance. It helps us find good combinations of settings, like a learning rate or a number of estimators, which helps us improve predictive accuracy. Now, as a result of this training, we get two key outputs. We get a trained model, which we package and deploy using a SageMaker endpoint. And we also get some evaluation metrics, which are monitored using Amazon CloudWatch, which we can see how the model performs over time. Now, once the model is deployed, we move on to the real-time inference flow. And here's how that works. When an end user, which you can't see here, but purple end user, wants to make a prediction, like get a forecast on a particular stock, they interact with the web application at the bottom of the diagram, and that app sends a request through a REST API, which is exposed through API Gateway. The request is then forwarded to an AWS Lambda function, which handles our business logic. Now, Lambda is responsible for processing the input, like pulling the latest feature values for a given stock, and formatting the data in the correct input structure to send to our SageMaker endpoint. And the SageMaker endpoint runs the trained XGBoost model on that data and returns a prediction, which could be a classification like buy or sell, or a numeric value like the expected return. Lambda then takes that prediction, formats it as a JSON response, and sends it back through API Gateway to the front end app where the user can see the results in real time. Quick overview of our AWS systems that we use for this. For data storage, we use AWS S3. For machine learning, which takes place inside of SageMaker, we use it for deployment and training, as well as the endpoint to expose it for real-time inference. For the API, we have our REST API exposed through API Gateway, with the business logic being handled by AWS Lambda, and all this monitoring is done using CloudWatch.
Hello. I'll be covering what we plan to do for building and deploying our machine learning model using AWS SageMaker. So why choose AWS SageMaker for trading models? We're planning to use SageMaker because it gives us everything we need to build, train, and deploy a machine learning model all in one place. It works really well with other AWS services like S3 for storage, Lambda for backend, logic, and API Gateway for connecting everything together. Since this project is all about real-time trading predictions, having a fast and scalable setup like this makes a lot of sense in my opinion. Next is market data pipeline and processing. To train the model, we're going to pull the market data from the AlphaVantage API, things like open and close prices, trading volume, and moving averages. We'll clean and prepare that data using Pandas and NumPy inside a SageMaker notebook, then store the processed data in an S3 bucket. That way, it's easy to access and ready for training whenever we need it. Building and training the model. We're planning to use XGBoost for the model since it's great for structured financial data. We'll do an 80-20 train test split and track how well it performs using metrics like RMSE and MAE. During training, we'll use CloudWatch to keep an eye on everything just to make sure it's learning properly and not overfitting. Deploying the model for live forecasting. Once the model is trained, the plan is to deploy it to a live SageMaker endpoint. We'll use Lambda and API Gateway so that our front end can send data to the model and get predictions back in real time. That way, the system will be able to answer questions like, will the stock go up tomorrow? Which is the goal for this trading setup.
Hello, my name is Lyric, and today I will be discussing the front end and back end setup for our machine learning trading system. So first, let's talk about the general overview of our setup. We will be using Amazon S3 in order to host our front end, which we will use with Amazon CloudFront. We plan on hosting the back end of our website with AWS Lambda, and we plan on hosting our machine learning model with Amazon SageMaker. We will then use Amazon API Gateway in order to connect our front end to our back end. Now let's talk about our front end with Amazon S3 and CloudFront. Amazon's simple storage service is Amazon S3. It is used as an object storage service. What we will use it for is to store the build files for our React front end. We will have source code in HTML, CSS, and JavaScript that will be used to create build files that will be stored in an S3 bucket. So once everything is deployed, the S3 bucket will serve as a static website, meaning users can access the app through a browser without needing a traditional web server. We will use Amazon CloudFront, which is Amazon's content delivery network, before and in front of S3 in order to help distribute our front end faster. It does this by caching files at edge locations close to users around the world. It will also add HTTPS support, which will make our app more secure and globally accessible. So we will be using Amazon S3 and CloudFront together in order to host the front end of our website. Next, we will be using AWS Lambda in order to host our backend. AWS Lambda is a serverless event-driven compute service. So how this works is Lambda will run in response to specific events. This can include a user interacting with our front end or a change in data that's stored in our S3 bucket. AWS Lambda is going to be used to build the core logic of our backend and will help process input or call our machine learning model that we host in SageMaker. Now let's talk about the API Gateway and SageMaker. Our API Gateway is going to be the secure bridge between the front end and back end of our website. What it will do is help receive incoming HTTP requests from our React app, and it will help route those to the Lambda function. So API Gateway will help with our communication. Now, SageMaker is going to be used to host our machine learning model. When a request comes in, Lambda will pass that input to SageMaker, which will run our model and generate a prediction. The SageMaker will pass these results back to Lambda, which will work their way back to the front end of our website and display those results for the user. So our SageMaker is used to power the predictive machine learning model. Lastly, I created a data flow diagram for how information will flow from our front end to our back end. So for example, a user will access our website, which will be routed through Amazon CloudFront to Amazon S3, where the React files are hosted. From there, the user will be able to input information and request a prediction from our machine learning model. From there, the API Gateway will take that request and pass it to AWS Lambda, which will then pass that information to our machine learning model in SageMaker. SageMaker will run and produce its prediction and pass the results back to AWS Lambda. AWS Lambda will pass this back to the API Gateway, which will then come back to the front end in our AWS S3 bucket, which will be used to display the results of the machine learning model in the user interface. So we use all of these AWS services in combination to create a serverless architecture for our machine learning model website.
So now we're going to talk about monitoring the trading system with AWS CloudWatch, which is what we're going to be using to maintain watch over the program as it runs. So when trading, it's really important to keep an eye on what's going on at all times because it can change rapidly, and that's what this is going to do. So it's going to be monitoring the SageMaker model performance, S3 and Lambda resource usage, and the API Gateway request response logs in order to catch any issues if they come up as fast as possible. And it's going to do this by creating real-time dashboards with data on how it's on performance and any issues that come up. It's going to collect any metrics and all metrics and logs based on how it's performing, and it's going to have any alarms for failure detection. So if there is any issues, it's going to let us know so we can fix it as soon as we possibly can. The idea is to keep it running smoothly, avoid any issues, and if issues do pop up, address them as quickly as possible, which is really important in the trading world. Okay. So we have an example of metrics and alerts. So the first thing is model latency tracking. It measures how long it takes for the ML model to respond to an inference request. And the reason it matters is because in algorithmic trading, delays can lead to missed opportunities and poor execution. The lower the latency, the less likely it is that we miss any sort of market changes in the real world, and it makes our model a lot more usable practically. Next, we are going to be monitoring S3 usage, which what S3 usage is it's how we track storage, access patterns, and request metrics for the S3 buckets. And it matters because, let's see, so it matters because S3 charges for storage and requests, so it's more about optimizing cost and making sure that the program runs smoothly while also costing as little as possible. And on top of keeping track of costs, you also need to detect unusual patterns, security risks, and make sure everything on the front end is working the way it should, and the program looks the way it should for users while also not posing any security risks or other errors for the user. Now, it's also going to be keeping track of alarms for error rates. So CloudWatch alarms notify you if certain conditions are met, such as too many errors being produced or the API failing altogether. And it matters because the faster the alerts happen, the faster we can respond to problems and fix them. And time is of the essence when trading. So, whenever failure is going on, you need to be able to address it as fast as possible in order to maintain a quality product. So those are just some examples of metrics and alerts that are going to be watched by AWS CloudWatch. Excuse me. Okay. Now, when we're doing this, we want to manage our resource and costs. We want it to use as little resources and cost as little as possible. Just in general, that's how you make pretty much anything, right? So we're using AWS budgets to kind of help control this. As you set a custom budget and receive alerts when you're approaching or exceeding it. So that way, as we go, we can make sure that we don't exceed our budget. And if we get close, we will be notified so we can kind of work around it a little bit and try and find better alternatives to certain things that we're using to maybe reduce costs and stay within budget. Then we're also going to use Cost Explorer, which is more of a visual tool. It's a dashboard tool that visualizes the AWS usage and cost trends over time. So it can explain if there's certain periods of heavy usage and lightened usage, we can see where that's occurring, why that's happening, and address it hopefully to reduce costs and usage in the future. So, and just some general ideas for optimizing, we could shut down idle SageMaker notebooks, so just less data usage while the application is running. We can use spot instances, and we can minimize cross-region transfers. All of that stuff should ideally optimize cost while also optimizing performance. So now we're going to talk about possible enhancements that can be made for the future. So once we're done with this thing, it's important to be mindful that it can always be improved. And how might that happen? So first thing is we can upgrade the model, right? We can use reinforcement learning, which means it interacts with the environment it's in and actually offers feedback so that we can kind of tweak it for the environment it's in, making it more of an adaptable type model. And then we also have sentiment analysis, which analyzes any sort of news or social media, any sort of outlets. It kind of helps us understand how the market is, and it helps us predict how the market is going to be. The whole point is to increase the prediction accuracy of the model and provide insight to the movement of different markets by using news and other media resources. And then finally, ways we can improve the system itself. We can use step functions, which allow coordination between multiple AWS services into workflows. And we can improve the manageability, scalability, and the user friendliness of the ML pipeline. So that's just general tweaks to improve user experience wherever it may be needed. It's kind of like a bit of a broad observation as far as enhancements can be made. But in general, you want to look at how your users are faring using your model, and you want to cater that experience as much as you can toward their needs. And then lastly, you can use auto scaling, which will automatically increase or decrease resources according to demand. So you don't want to be using too many resources if you don't need them, and you don't want a situation where more resources are required and you don't have them. So over time, we'll be able to gauge how many resources are required for certain tasks and allocate those resources for those tasks without sending too many or without sending too little. Those two things combined will greatly improve the model's usability. Okay. And then finally, extending functionality. So just ways we can build on its current functionality, right? So we can have ideas for the front end specifically. We can use a real-time trading dashboard. So an interface with live predictions, trades, and market movements. It's just a visual tool for users to kind of understand what's going on in real time so that they can make they can assess what's happening and make decisions. And then interactive performance graphs are another really, really good visual tool for people to use that will show the accuracy of the model, prediction history, and profit loss over time, etc. So it will list all sorts of different metrics that we can use to improve the model's efficiency, and it can also be used by users to improve the proficiency of their own usage of the model. So we can improve the model, but users can also improve their ability to use the model. So it works both ways. It's really nice that way. And then as far as security goes, obviously when trading, talking about money, security is always super important. So first idea would be the AWS Web Application Firewall. So the idea is to protect application APIs and front end from common web exploits, SQL injections, DDoS attacks, etc. So just general security. It's always a good idea, especially when talking about money, right? And then the second thing is IAM role refinement. So you want to manage AWS identities and access management roles following principle of least privilege. So you want higher ranking individuals having more access to different aspects of the model than less ranking individuals, and it kind of scales depending on hierarchy and position of each individual, of each user. That way it ensures that each user only has access to the necessary features for their particular role, and it kind of helps manage resources as well, while not allocating too much to a role that doesn't require very much and not failing to allocate enough to a role which requires more. So that's the ideas behind extending the functionality of the model.